So I think this is a good summary problem that illustrates the concepts of the ideal gas law, stoichiometry, as well as Dalton's law of partial pressures all in one problem. So let's talk through this problem and solve it. So let's say we have some zinc solid. We've dissolved it in hydrochloric acid, and we've produced hydrogen gas. And we've collected that gas by water displacement. And so I give you the pressure due to water vapor in millimeters of mercury, and I also give you a total pressure at a particular temperature, 25 Celsius. We collect 3.8 liters of hydrogen gas. Two parts to this question. We want to know how many moles of hydrogen gas were collected and how many moles of HCl reacted in this chemical equation. So, when taking stock of the information that was given to us, we have a bunch of information given with regards to the hydrogen gas. We have the volume in liters. We have the temperature was in Celsius, but we can go ahead and convert that to Kelvin. For the pressure of hydrogen, here is where we're going to have to use Dalton's law of partial pressures because we collected this gas over water. The pressure of the hydrogen gas is going to be equal to the total pressure of the system, which was given as 760, subtracted from the partial pressure of water, which was given as 23.8 millimeters of mercury. When doing that subtraction, we then get 736.2 millimeters of mercury. So that is going to be our pressure of hydrogen gas. So that, along with the gas constant and volume and temperature, allows us to use the ideal gas law to solve for N, specifically moles of hydrogen gas. But hopefully you caught on by now that before I start plugging in information of pressure, temperature, and volume, I have to do one conversion. I have to convert my pressure from millimeters of mercury to atmospheres. So I have a pressure of H2 in atmospheres because that is the unit that's used in the ideal gas law. So we now have a pressure of hydrogen gas, a temperature, a volume of hydrogen gas. We can solve for the number of moles of hydrogen gas. And we see our units cancel appropriately. And so then doing that multiplication and division gives us 0.15 moles of hydrogen gas. So that's the first part to this problem. The second part to this problem makes use of the stoichiometry of the chemical equation. Mainly the fact that for every 2 moles of HCl, you have 1 mole of hydrogen gas. So we can take that statement and write it as a conversion factor, which is done down here. We write that conversion factor such so that my moles of hydrogen gas cancel. I'm left with moles of HCl to give a final answer of 0.30 moles of HCl. So I think this is a good problem that kind of illustrates some of the various facets of the ideal gas law, stoichiometry, and Dalton's law of partial pressures that was discussed previously.